Okay, good afternoon. This is Mr. Farrell. This is our bonus Wednesday graphing basics video. To do this assignment, go to Schoology at this time, open up the bonus Wednesday assignment, and it'll be a Kami document that'll look just pretty much just exactly like this. Now, what I expect you to do is I expect you to type in using the text feature in Kami in these boxes that you see around your graph. I'll be uncovering the words on mine, so you just type in the words on yours. And the nice thing about this video is you can stop and do that as we go. So here we have a graph. So what is a graph? Well, starting in the upper left-hand corner, you'll see some bullet points there. Well, a graph is a picture. It tells us a story about a mathematical relationship. And that relationship is between the x and the y axis and values. So it's about a picture, it's about a relationship, and so it's helping us take an equation or a linear equation or a wave or various types of things. You'll be seeing graphs all the way through high school and into real life. But it's talking about a relationship. And also, too, it's precise. A graph has ordered pairs, x and y. And so you're able to say, well, this is a point. Like, for example, I could make the point right here. This is 2, 3. And x is always first, x and y. And so it's a precise, it's telling you exactly where that is. And then once you understand the context or the setting of this equation or what's going on, then you're able to determine what those locations mean. So how is a graph formed? A graph is formed by two number lines intersecting each other right here where this big red dot is. And that would be, of course, if we're looking at the x-axis, that would be 0. And so the x-axis is the horizontal axis. And again, you can stop this video anytime and type the words in. But that's your horizontal axis. And what does the horizontal mean? Well, that means it goes left to right. And all your positive x values are to the right of 0. All your negative x values are to the left of 0, of course. Your y-axis is a vertical axis. That means that it goes from top to bottom. And again, from the red dot here being 0, all the y values above that are going to be positive, and all the y values below it are going to be negative. So that's how a graph is formed, by the intersection of two number lines. And after that intersection occurs, then what do you have? Well, you have 4 distinct areas of the graph. They're called quadrants. So we have quadrant 1 right here, and notice all of the x values are positive, all the y values are positive also. I call that our happy place because it's very positive. And so also put this in that box, positive. So if I give you values that like 2, 3 and asked you which quadrant they'd be in, you would say, well, they'd be in quadrant 1. Well, quadrant 2 is located over here to the left of quadrant 1. We're going counterclockwise. And so quadrant 2 is to the left of quadrant 1. And notice the way they're numbered. These are Roman numerals here. Roman numerals are like this. 1, and they're like capital I. 2, you get 2 I's. 3, yep, you get 3 I's. 4, let me talk about 5 first. 5 is V. So 4, the Romans came up with this system saying, well, let's go 1 subtract from 5 and you get 4. So that's the way the quadrants need to be labeled. So in the quadrant 2, your x values are negative, your y values are positive. Negative, positive. Down here is quadrant 3, below quadrant 2. And you have, again, Roman numerals, 3 capital I's there. And your x values are negative, and your y values are negative. So this is a real negative place to be. So if I see you in the hall and I say, hey, how's it going? And you can say, oh, Mr. Farrell, I'm feeling quadrant 3 today. I'll say, got it. I understand how you're feeling. Quadrant 4, which is left over here, of course. And again, notice Roman numerals, I, capital V, indicate 4 in Roman numerals. This is where all your x values are positive, all your y values are negative. So that's positive, negative. Now, I mentioned that this graph is formed by the intersection of two number lines. Well, that's right here at 0. Well, that's got a special name too. It's called the origin, O-R-I-G-I-N, the origin. And the coordinates or ordered pair for the origin would be 0, 0, because 0 that's where x is 0, and that's where y is 0. And that's really where the graph begins, is that intersection point or the origin. So now one last thing I want to touch upon is the numbering system that you see here with x and y axis. You can see we're counting by ones here, and same thing for y. Well, that's called scale. Scale is the numbering system, the intervals that you decide you're going to have in your graph. Now, what's neat about that is that you can do any type of numbering system for x and for y, depending upon what your information is or what your data is. And this is, again, what graphs are about. It's a picture of data. So you should have all those typed in your document. And so let's go forward. And what I want you to do is scroll down, and you will find this. And here we have a data table. A data table is information organized into columns and rows. And they're categorized into x values and y values. Because remember, whenever we're talking about ordered pairs, we go x and y. And be careful to always make sure you put parentheses around your ordered pairs, because if you don't, then they're just some numbers with a comma in between them, and people may not know what exactly you're talking about. So here we have a data table where we have x column and a y column. And down here, I didn't put this in your notes, but you might want to draw this one right here. This one we're going to call data table B. This is data table A. Data table B is where your x values are in rows and your y values are in rows. And I can transfer this information from this data table. So it's like 1, 2, 2, 4, and 3, 6. And once again, you can use the shape feature on the left-hand side of your Kami document, pull out some lines and create your little table, or just draw it in yourself. So now I'm going to go ahead and take this data table and plot it on this graph. Because like I said, you can take and write down the ordered pairs if you wanted to, but after a while you should be able to pull them off of there, because you know x is always first and then y coordinates are next. So here we go. 1, 2, then 2, 3, 4. So here is -2, -4. That's that point right there. Now I did these little jumps here because it kind of helps illustrate what we're doing. But you may not need that, and after a while I hope you don't need that. But then we got -1, 2. So I'll go -1, 1, 2 right there. Then I have 0, 0 right here in the center. Then I have positive 1, y being positive 2. And then x is 2, y is 4. X is 3, y is 6. So I should place it right about there. So now, depending upon the context or the setting of this problem, that might be enough. They may be just asking for the points to be plotted given the information or the data that you have. But a lot of times most of the time, you're going to be doing linear type of solutions. And so you'd connect all these dots like this. And if it's a linear equation, it's probably going to go on forever in both directions. So that's how you graph from a data table. Now at the bottom of that document, I left you some space and I want you to write some other things down there, or you can just hit the plus sign at the bottom of your Kami document and add a new page. One last thing we're going to cover is x values and y values. What are they? What do they represent? The x values are independent variables, kind of like middle school students. They like to hold on one second here. They like to do stuff. They like to take action. And it's stuff that happens by itself. Whoops, sorry. And so independent variables is like, for example, when I take Maggie for a walk, I have a ball and I throw the ball for her. Well, that would be the independent variable, the number of times I throw the ball. So for example, I can start graphing down here. the number of throws that I do. So I have 1, 2, 3, 4, 5 throws. So I keep track of the number of times I throw the ball. The dependent variable is your y value, and that means that you take, and if this happens by itself, this one relies upon the action. It reacts. So if I'm throwing the ball, what's a natural reaction? Well, the reaction would be, how far does it go? And that's what I'm going to graph here on the y-axis. So, and I'm going to do that in feet. And now here I'm going to use a scale by counting by 5s. So here we go. So here I have, in my first throw, I go 25 feet. The second throw, I go 20 feet. The third throw, I go 15 feet, 10 feet, and then 5 feet. And then I graph those values here. Just coordinate x value first and then y. And then I'm going to connect all those dots with a line like that. So this is a demonstration of how the number of throws, your independent variable, because this is your x-axis here, and this is your y-axis here, and y is a dependent variable. So what you have is me throwing the ball, and the dependent variable is how far it goes after I throw it. And then by analyzing this, taking this picture and this graph, I can see that over time, the more throws I make, the less distance it goes. So a natural conclusion would be that I'm getting tired. So those are the basics of graphing, and this should be able to fill this out and then submit this document. This is a 5-point assignment. If you have any questions, please let me know. Thank you.